In the previous videos, we introduced merge function. We also introduced merge sort. We discussed that merge sort is a divide and conquer algorithm. It is strongly recommended to see those videos first before coming to this video. Let us now talk about merge sort algorithm. How does this work? As we discussed, merge sort is a divide and conquer algorithm. We take an input array and we also take two indexes, L and R. L is the first index of this array. If your array is 0 based, then it's going to be 0. R is last index, which is the last index of your array. So 0, 1, 2, 3, 4. So if for this array, L is going to be 0 and R is going to be 4. Right. What do we do after taking the input array? We first check this. Does this input array contain at least two elements? Because if there is one element in your input array, then there is nothing required to be done. It's already sorted. To do something on your input array, to do divide and then sort and then merge, we need to have at least two elements. So we put this condition. At least two elements should be there. Then only we perform our merge sort logic. Otherwise, we do not do anything. After checking for at least two elements, we find the midpoint of our input. So this expression that I have written here, it is same as L plus R by 2. It's same as. The purpose of writing L plus R by 2 is to avoid overflow. What happens in merge sort and binary search algorithms, if they do this L plus R by 2, and if L and R are high, then there might be overflow for large arrays. If you are not getting it now, we'll discuss it in detail after we discuss the merge sort algorithm. But the idea of this expression, the meaning of this expression is same as this. The only purpose here is to avoid overflow. We'll talk about this in more detail. So we find the midpoint for our input array. That's what we do here. So we have 0 and 4 and mid is going to be 0 plus 4 by 2. Or if we follow the expression here, it's same as R plus L by 2. So we'll get 0 plus 4 minus 0 by 2. Right. So we'll get 2. We get 2 as a midpoint. After finding the midpoint, we recursively sort the array from L to mid. So we have the midpoint M as 2, right? So this is where M is. We recursively sort this half, right? And we assume that our merge sort function works. So this sort is going to sort this array to 5, 10, 30, right? We'll discuss in detail like how does this happen. Actually, it happens due to merge function. But we recursively sort this left half, and after that we recursively sort the right half. So we get 7, 15. Right? These two arrays we get, these two sub-arrays of input array are sorted by these two calls. After sorting these two sub-arrays, the half-half sub-arrays, we call the merge function. And what merge function does, it takes this half, it takes this half, and it merges these two. And we have talked about merge function. So what it is going to do, it is going to merge these two sorted sub-arrays of our input array. So what we'll get after merging these two, we'll get 5, 7, 10, 15, 30. And that's a sorted array. So our input array is modified to this thing, right? So we get the sort in this way. So what we do in merge sort, we first check if there are at least two elements, right? If there is one element, there's no point sorting. After checking this, we find the midpoint, right? After finding the midpoint, we recursively sort elements from low to mid. And then we recursively sort elements from mid plus 1 to R. After sorting these two halves, we merge these two halves. And merge, how does merge work? It takes two sorted arrays, which are two sorted halves of your input, right? So it considers one sorted array from L2, array L2 array M and other sorted array from M plus 1 to R. And we tell this merge function that this is the point to which you need to consider the left half. And after considering these two sorted subarrays, a merge function simply does the merge logic and makes one sorted array. Let us now do a dry run of this algorithm. How does this work? So let's take this input array. We have L is 0 and R is 4. So our function begins its execution from here. So R is greater than L, R is 4, L is 0. So we come inside. When we come inside, we find the middle point. Our middle point is 2 after doing this computation. Now we come here. So our main function, which was called from 0 to 4, is now here. And what it does here, it makes a recursive call. It makes a recursive call for 0 to 2, low to M. 10, 5, 30. Now recursive call function begins with L equal to 0 and R equal to 2, right? Your new values are 0 and 2 in the recursive call. This is 0 and this is 2. So this recursive call also goes inside this if condition because R is greater than L. And what it does, it finds the M, and what is M? M is 1. Right? Here M is 1. Right? It does 0, it considers L as 0 and R is 2 and finds the midpoint. After finding the midpoint, this function also calls merge sort from L to M, which is 0 to 1. L is equal to 0, R is equal to 1 for this particular left call. And this function now begins its execution, and this will begin its execution from the same point. And it checks R is greater than L. So it will find the midpoint. What is the midpoint now? 0 plus 1 minus 0 by 2, which is 0. So you will get the midpoint as 0. So it again makes a call for merge sort with single element. L is 0 and R is also 0. Single element 10. So when this call is made, this also begins its execution from this point. And what happens in this call? It does not go inside this if condition because R is not greater than L. So it stops here, right? So this function call simply finishes and gives the control back to its parent call. So now the control comes to this function call with L equal to 0 and R equal to 1. It was waiting for this to finish. It has finished because it didn't go inside this condition. It calls the other thing. So this parent call now makes a call for M plus 1 to R. So L is now M plus 1, which is 1. R is 1 and 5. So this call is made here for L equal to 0 and R is equal to 1 function call. And when you call this, a new function call begins from here. And R is not greater than L. So this call will simply not go inside this if condition. It will simply return the control back to the parent because this is over. So now the control comes here to the parent call with L equal to 0 and R equal to 1. So what does parent do? Parent was waiting for this was finished here. It was then waiting for this was finished here. So parent call now comes here, merge LMR. So what it is going to do? It is going to call merge for this subarray and this subarray. LMR, which means 0, 0, 1. It's going to make a merge call with 0, 0, 1. Right? And what merge is going to do? It's going to merge this with this. So this is greater. So when merge happens, this will become 5. Right? It will become 5. And this will become 10. Right? So these two finished their call. They returned the control back to the parent, and parent call came into the merge function and merged these two subarrays. Right? So they merged. After doing the merge, this call L equal to 0 and R equal to 1 is done. It has finished its work. Now it finishes, so control comes back to the parent. Now parent call which was waiting here right? To finish the left call to be over, now it makes a call to the right child, the other recursive call, right? So it makes a recursive call for m plus 1 to r. M is 1, m plus 1 is 2. So your L is 2 and r is 2, which is 30. So this call begins now, and when this call begins, what happens? It checks for this condition. R is not greater than L, so this call simply finishes, it's over, and it gives the control back to the parent. And for parent, L is 0 and R is 2 and M is 1. So for parent, this call is over, this call is over. Now what will parent call do? It will come inside this merge function. It will come inside this merge function, and inside this merge function, what it will do? It will merge the elements from L to M, which means 0 to 1, and then M plus 1 to R, which means 2 to 2. So it will merge these two subarrays. So when these are merged, what will you get? What will merge function do? It will simply bring them together in a sorted way. So you will get 5 and 10 and 30, right? When these two are merged. So this function call, which was called for L equal to 0 and R equal to 2, has done everything. It has made two recursive calls, and it has called merge as well. And merge has done its work. It has merged these two arrays. Now this will give the control back to its parent. And what is the parent of it? Our original function, L equal to 0 and R equal to 4. So what will parent do? The parent was waiting for left call, which is over now. The left call has given control back to the parent. So parent will make this call. And what this call is? This call is for M plus 1 to R. So what is M? What is L? L is 3 and R is 4, which means you have elements from 15 and 7. So this recursive call is made here by the original function call, right? Because this got control back, because this got finished. So our original function call got the control back. And once it got the control back, it started executing the next line, which is this line. Now what this recursive call do? It will make first recursive call for here, right? First it will find the midpoint and then make recursive call here. What is midpoint for this? 3 plus 4 by 2, which is 3. So it will make two recursive calls. L to M, which means 3 to 3, L is 3 and R is 3. And then it will make one more recursive call for M plus 1 to R. So what is M plus 1? 3 plus 1, 4. So L is 4 and R is also 4. 7. And then once these two calls are over, this will merge. So it will make it 715. So this write call is also over. Now the control goes back to our original function call. Now what it is going to do? It is going to call merge. It is going to call merge from 0 to 2 and 3 to 4. Please note that the modifications that I have been making, they are done in the same array. So this array which is written here, it is actually modified. It is modified. It has become 5, 10, 30. So this was our input array. After these two calls, our input array has been changed to this, right? Now it is calling the merge function. And what merge function will do? It will merge this part and this part. So these two parts will be merged, and merging will simply combine them into one sorted array. So your input array is changed to 5, 7, 10, 15 and 30, right? So this is how your input array is sorted. We divided our input array into two parts, recursively called merge sort for the left half, then recursively called merge sort for the right half, which means we sorted left half and right half, and then our merge function combined these two sorted arrays.